All right, so going to kind of look at a couple more sum of two cubes and difference of two cubes. I mean, the first thing you just look at your sign. I mean, this one's a positive. So, I mean, we're looking at this first formula up here. Um, we want to be able to pull out our A and our B. So your A is whatever makes, like, what cubed would give you this first term? Like, what up to the third power would give you 8x to the third? And then we want to figure out what up to the third would give you 1. So, I mean, 1 is just going to be 1 up to the third power. So our B is 1. Our A, first just look at the number. What number up to the third power would give you 8? Well, that would be 2, like 2 times 2 times 2. And then for your variable, I mean, what up to the third power would give you x to the third? Well, just x, right? So our A would be 2x. So that's how you pull out your A and B in these formulas. So some books use like X's and Y's instead of A's and B's, just like a heads up. I know some of those like YouTube videos I posted, it's the same thing, but it would be with X's and Y's. So um, just so you're aware if you see it. I mean, that's so we're going to plug this into this formula. So we're going to have our first parentheses is just 2x plus 1. So it's the same sign. So it's a plus in the first one. And then we're going to have, and here, I'm just going to cut. I'm just going to, oh, can I delete this? Why won't it let me cut it? I'm going to just do this one lower. I just don't have the space. But in the second group, sorry about that, it would be 2x squared. So make sure you square the whole thing. That would be 4x squared. Because remember, you're doing 2x up to the second power. So you got to square both parts, like the 2 and the x. And then minus a times b, well, 1 times 2x would just be 2x. And then plus b squared, well, 1 squared is just 1. In Delta Math, like on your assignment today, this is where you're going to stop. They're not actually going to have you solve it in Delta Math. They're just going to have you factor it. So kind of take that as a blessing, because solving these can be a pain. But if you're solving these, I mean, this first one, like if you set 2x plus 1 equal to 0 and solve, well, you would subtract the 1 over, divide by 2. I mean, you would just get negative 1/2 or negative 0.5. It's up to you if you want to put a decimal or a fraction. Like I said, I don't have a preference. The second one, you probably want to use quadratic formula, but keep in mind, you're always going to get two imaginary solutions. Like, so this is not going to work out pretty. Like, I mean, we're going to get an I in our answer. So if you just plug it into the quadratic formula, it's negative b. So that would really be negative negative 2 plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So 2 times 4. So if you clean this up, I mean, that's going to be a 2. That's going to be an 8 on the bottom. If you kind of simplify this in your calculator, or if you can kind of do it mentally, that would really be 4 minus 16. So that would be this, oops, not the highlighter. That would be the square root of negative 12. So this would really be 2 plus or minus, and the square root of 12. I usually like to put it as a decimal. I mean, you could just put the square root of 12i if you want to keep it as a radical. I usually like to get the decimals if I can. But that's just, I don't know, that's just me. But it's it's about 3.46 I. And if you want, you could divide each one of these parts by 8. So I mean, like that would be 0.25 plus or minus 3.46 divided by 8 would be roughly 0.43 I. I rounded it a little bit though. But keep in mind, in Delta Math today, you're not actually going to have to solve these. But I want you to see how you would get your solutions from something like this, because you might have to solve these depending on what they're asking you to do. But in Delta Math, like I said, you would actually, this is what you would put in your answer box, like here, like your factored form. But keep in mind, if you're actually trying to find your solutions, then you got to solve each piece of this factored form in that. And this will be true for all of these sum of two cubes or difference of two cube questions. You're always going to get one real solution from like your first binomial, and then you're going to get two imaginary solutions from your trinomial part, like your second piece. So like you'll always kind of, your answers will always kind of fall into this pattern. So for this last one, I'm just going to get it set up because like I said, this is what you're going to see in delta math. So we have 125x to the third minus 27 equals 0. So the first thing I just want to make sure we're understanding, like, and if you want me to send me your answer in the chat, like what would our A and what would our B be from this formula? Like what cubed would give you that first term and what cubed would give you that second term in this equation? So see if we're understand. I mean, because if you're understanding that, I mean, you're going to be in good shape, at least for what you see in delta math. Okay, good. Don't forget your variable part. Some people send me your answer, but Aslan, that looks good for the first one. Mikhail, you look good. Like I said, just don't forget your variable part. All right, but a few people sent me, and like I said, I want to make sure you have time to work on your delta math today. So sorry if I'm cutting it off, but you should get that 5x is your A because 5x up to the third power would be 125x to the third because 5 times 5 times 5 is 125, and then x times x times x would be x to the third. And then 27 is a perfect cube. That would be 3 to the third power. And you don't worry about your sign. What is it not letting me write? There it goes. And if it's helpful at all, we talked about this a little bit yesterday. These are some of your perfect cubes. You're usually not going to get anything too much bigger than this. Oh, that got cut off. But like 1 to the third power is 1, 2 to the third is 8, 3 to the third is 27, 4 to the third, sorry, is 64, 5 to the third is 125. I mean, but you could always check in your calculator really quick, just start putting numbers up to the third power to see what it would be. You can always kind of try and guess and check a little bit, especially if you know it's one of these types of questions. So this is a difference of cubes. So we're just going to have our A minus B. It's the same sign, so 5x minus 3. And then we would have A squared. So just make sure when you square it, you got to square this whole thing here. So that would be 25x squared. You got to square the coefficient as well. And then A times B, well, that would be 3 times 5x. That would be 15x. And then plus B squared, that would be 3 squared. So that would be 9. And for this problem, I'm just going to stop here because, like I said, this is what you're going to have to do in your delta math. But if you were going to solve this, I mean, you would just, solve that first one, add the 3 over, divide by 5, you would get 3/5. And then you're going to want to do, like, probably use quadratic formula to solve that trinomial. And like I said, you will always get an I in your answers for that one. Like, so you're always going to get a negative number underneath your radical part. So that's sum of two cubes, difference of two cubes. I'll be honest with you, I don't know how much you'll have to use this to actually solve, but a lot of times you will need to use it to kind of factor down. And these, like I said, these formulas are hard to memorize, so that SOAP can help you with your signs. I mean, in this course, I'll probably give you these formulas, I'll let you look, but I mean, some classes, I mean, they'll expect you to kind of memorize or know this formula, so that acronym can kind of help you if that is something you need to do in a future class potentially. So there was one more type of question I wanted to look at. It's a little bit strange, and honestly, I don't, unless I can find it, I cannot find this type of question in Delta Math. I might just be looking up the wrong thing. But so you probably won't see these in your assignment today, but I still wanted to show you how kind of another kind of method you can use sometimes to solve these. It's kind of like a little trick. And honestly, it can be kind of, you might not recognize to do this in the future unless it fits this perfect pattern. So I'm just going to put a star by what we're doing right now. If what I'm doing over these doesn't make a whole lot of sense, don't stress too much. I just want to show you, like, this is how you can solve these by using substitution. So for example, like this only really works if you have it exactly in this pattern. You have like a fourth power, you have an x squared and a constant. So it's kind of it's a pretty special situation. So honestly, I guess I want you to see this just in case maybe you do this in a future class. But really what we're going to do is we're going to set a equal to x squared. So we don't have any methods to solve a quartic function or a function up to the fourth power, and we can't pull out a GCF. Like we can't pull out an X to make this into something we can deal with. So one way you can deal with some special cases like this is use substitution. If we can rewrite this problem, if I let a be x squared, I could rewrite this problem as a squared, oops, because x squared to the second power would be x to the fourth, minus 3a, since a is x squared, minus 4 equal to 0. With this substitution, now I have a quadratic that I could solve. So I can factor this. So what multiplies to -4 and adds up to -3? Well, that would be minus a minus 4 and a plus 1. And then before I solve this, like I'm not just going to get a equals 4, a equals -1. I would just, you're going to substitute it back in since a is that. And now we could solve these. Like if I solved x squared minus 4 equal to 0, I would add the 4 over, square root both sides. You would get plus or minus 2. And this one, if you solved x squared plus 1 equals 0, you would get x squared equals -1. If you square root that, you're going to get x equals plus or minus I, because hopefully that makes, like I said, we're just setting each one of these equal to 0 and solving. Like that's how I got my answers there, just in case anyone's like, what? Like if you solve these, this is what you'll get. So this is a pretty special case, like I said, the substitution, but sometimes you can kind of set a variable equal to something and plug it in to turn it into something you can solve. But honestly, even myself, like a lot of times if I see these problems, I probably wouldn't recognize. I know I can do this sometimes, but it's not one of those things you often see unless they're telling you using this method. So that's why I kind of put an asterisk by this. It's nice, but it only works in very specific situations. And at least for me, I don't know, maybe I'm just not as advanced, but I mean, I don't think I'm that bad, but like, I don't like when I see a problem like this, this wouldn't probably be my first idea, even though this is a great way to solve this. But like you could do the same thing here. And it doesn't have to be an a equal to x squared. Like for example, you could substitute like in an x cubed or something, but honestly, like I said, if this doesn't make sense, don't worry too much, because honestly, this probably isn't something you're going to see a whole lot of. But like it basically lets you turn it into a quadratic or something you can deal with. Like this one, you would have a minus 9 and then a minus 1. And sorry, my lowercase a's look like 9. So that's, I'll just put a capital A. These are my a's. So then you could substitute back what you had. And then if you solve these, I mean, you would get plus or minus 3. You would get plus or minus 1. Okay, so that's it for our notes. I'm going to